Hello everyone, welcome to Physmatica. Let's take a look at this problem. The problem says, given f of x, determine how many integers belong to the domain of g of x. So the first step is, let's take a look at g of x. If you take a look at g of x, we want this to be non-negative because it is a square root, okay? But the idea here and the point here, we want f of x over f of x plus 2 to actually be negative. Why is that? The reason is there is a negative under this square root. If you take a look at this and pay attention to that, there is a negative under the square root over there. So we want f of x over f of x plus 2 to be negative or 0. So when multiplied by that negative, it's going to give us a non-negative solution. So that's what we're going to look for, and that's how we're going to identify the signs. So now we know that this is f of x. We have 1 and we have minus 2. And the whole point of this problem is to know this idea that if we have a function like f of x plus or minus a, or f of x plus or minus a in these forms, what's the difference? That's the whole idea, and how this transformation actually shifts a function. So when we have it in this form, remember that this shifts the function to left and right, and in this format it's going to be up and down. And that's all you need to know to solve this problem, because what we need here, we actually need to find out how does f of x plus 2 actually looks like. So now let's try to derive f of x plus 2. So it's going to be like this. So 1 is going to be minus 1 because we are shifting them 2 units to the left. And remember, it's going to the left because this is positive, x plus 2. So 0 is going to be minus 2, and minus 2 is going to be minus 4, something like this. And nothing else going to change. So the function is going to be the same. So it's going to exactly look like before, something like that. It actually passes through minus 2 as well. So that is f of x plus 2. And now it is very easy to solve. All we need to do is to just determine the signs. We have x, we have g of x, we have minus 4, we have minus 2, we have minus 1, we have 0, and we have 1. These are very important. You need to know exactly which one of these roots is actually in the function and defined and which is not. As you can clearly see, 0 and 1 are already defined. Why is that? Because if you take a look at the f of x function right here or there, doesn't matter, you can see that 0 and 1 make this function 0 because it's going to be f of x is going to be 0. So this is going to be 0, and it is allowed. It's not the denominator, but minus 2 is also in the f of x plus 2. So minus 2 is not, we already know that this is not in the function, and this one and this one as well. The reason is that because it's going to make the f of x plus 2 0, and that's the denominator. So we can have that. That one is already solved. Now let's just jump into solving this and see what are the signs when it's less than minus 4. So what are the signs for the f of x over f of x plus 2 when x is less than minus 4? So we need to take a look at the graphs that we plotted. So when f of x is less than minus 2, right here, for example, something like this, imagine we are looking at minus 4. If you take a look at this, you can see that this is still minus. So f of x is negative when it's less than minus 4. How about f of x plus 2? F of x plus 2, when it's less than minus 4, something like minus 5, is also negative, okay? So we have two negatives, so it's going to give us a positive, okay? So this is going to be positive when g of x is, when x is less than minus 4. And remember, we are analyzing two functions, f of x over f of x plus 2 separately just by looking at the graphs that we plotted. Now let's just do that again for when x is between minus 4 and minus 2. So when x is between minus 4 and minus 2, if I just change the color here, between minus 4 and minus 2, it's going to be right here for f of x plus 2. As you can see, it is positive. And for f of x between -4 and -2, it's going to be this is negative. So we have a negative, we have a positive, we are going to get a negative. Perfect. How about -2 to -1? For -2 to -1, f of x plus 2 is negative. And from -2 to -1, which is going to be here, f of x is positive. So we're going to get another negative right there. Let me just change the color, makes it a bit better. It's going to be negative over there. It is very clear now. So from -1 to 0, so -1 to 0 for f of x plus 2 is going to be here. As you can see, it is positive because the graph is just increasing now. So that's going to be positive. And for -1 to 0 for f of x -1 to 0 right here, it is also positive. So we have two positive, it's going to be positive. And now from 0 to 1, from 0 to 1, f of x plus 2 is positive, and from 0 to 1, f of x is actually negative. So we have a negative here, and for the rest of that is going to be positive. Why? Because when it's more than 1, both f of x plus 2 and f of x are both positive. So that's fine. And now let's take a look at the solution. What is the solution? If we take a look at this, all we need to know is the minus parts. Why is that again? Because as you take a look at the g of x, there is a square root that is being multiplied by a minus. So we only can have the minus here. So this solution is actually positive and our g of x is non-negative. So we only want the negative parts. And if you take a look at this, and I'm going to just simply write this like this, we want this solution -2 and -1 with 0 and 1 both included, because we just take a look at the f of x and we can see that 0 and 1 are actually roots of the function, because it's going to make the numerator 0, not the denominator. But again, the question is asking us how many integers are there. So we have two integers here, and from -4 to -2 we also have -3. So the answer or the solution is going to be 3 integers. And that's the solution. I hope you liked it. Thank you for watching.